Algebra 2, we're looking at section 11.6. So on 11.6, we talk about analyzing data. Okay, so there are different things that we look at when we start analyzing data. There's many different ways to go about this. Depends upon what type of data we have, how we look at this data, what we're trying to reference towards. We're just going to talk about some of the basics that go into data itself. We talk about measure of central tendency. So measure of central tendency. Okay, if we want to measure a list of numbers and we want to try to see, well, what is about the center? There are a couple things we look at. We look at the mean, the median, or the mode. And each of these has a very specific time in which we use it, and we want to reference what's going on with it. Also on this, we also talk about the range. Once again, it's not listed with our measure of central tendency because this is our extremities, but it does give us a way of then comparing what's centralized within here. Okay, so our mean, this was what was known as average, but do realize any single one of these could be called average, and average just means a measure of central tendency. So I'm going to go like this. This is average. Okay, some sort of measure of center. Okay, it's a central part of whatever's going on. That's an average. So the mean is very defined. It talks about taking the sum of all data. So we're going to take the summation of all our data. So sum of all data. And then we divide it by the number of the data values. So the number of values. Okay, so in other classes you might see the summation of x's divided by n, which is the number of the x's that would be here. So once again, this is capital sigma. Kind of stands for summation. It tells us to add all the values that are present here, and then we're going to divide by the number that we have. The median talks about the middle. Okay, so the middle has a couple distinct things that we can talk about. Okay, if we have an odd number in our set, we have a direct middle. Okay, so we actually have a number that is in the middle. Because of that odd number, we'll have so many below, so many above, and that odd one would be right in the middle of it. Now, if we have an even set of data, this means that we will have to take the mean of the middle two numbers. Okay, so basically we'll have to find the middle of the middle two, and that'll be our median. The mode appears the most. Okay, this appears the most. And then the range tells us the spread. Okay, so the range tells us how are we spreading our data out. Are we from what number to what number? So basically we take the largest number minus the smallest number, and this gives us a value. It tells us how many numbers are we spreading overall. Now, each of these have a very specific time that they are the best. Okay, so the mean tells us if we have numbers. Okay, so if we were dealing with numbers, this will tell us the center as long as there is no outliers. Okay, so no outliers. Okay, if we have outliers, then the median. So if they're outliers, then we have the median. The mode is never used for central tendency unless we're dealing with something that's not numbers. For instance, eye color. You know, if we want to have a central or figure out what's the center eye color in a class, well, then we have to go by mode, because one of the things here to think about is how do we distinguish a color to numbers? Because once again, these deal with numbers. This generally deals with not numbers, if we're going to use it. Now, we do have modes with numbers. We could have more than one mode. We could have 2, 3, 4, so there are more than one modes that have possibility in here. And then the range is never used for central tendency, okay? Basically, the range is just telling us an overall spread of what we're talking about within here. Now, I did mention outliers, okay? An outlier. So an outlier is a number that does not belong with the set. So it does not belong. Okay. Now it doesn't mean it's not part of the set. It just doesn't fit in with everything that's going on. Okay. So in statistics class, there are different things we look at with outliers, whether it's truly an outlier or not. Tests towards it, tests against it. A lot of times, and in this class, we're going to look at two ways to look at outliers. Okay, an outlier basically can be done using common sense. Okay, does it appear that this number works? Is it fitting in with all the rest of them? Okay, that's what we kind of start looking towards. Now, this is the first way. There will be a second way here. Now, I'm going to come back to this second way because I got to show you something else before the second way will make sense. So to understand this second way here, we're going to have to first cover the Box-and-Whisker plot, okay, which is the other part of this data. Okay, so the Box-and-Whisker plot. So Box-and-Whisker plot. In the Box-and-Whisker plot, we basically have what's known as a 5-number summary. So 5-number summary. Okay, so depending upon what you're looking at, what textbooks, they might reference some of these things as 1. Okay, in a Box-and-Whisker plot, we talk about the minimum, quartile 1, quartile 2, quartile 3, and the maximum. Okay, so these are our 5 numbers. The minimum number is the lowest number. It's the value that is the smallest in the set. The maximum is the highest number, or the largest number. Okay, once again, we sometimes talk about this as a lower extreme and then an upper extreme. Okay, they kind of tell us our range. Okay, so that range is at highest minus the lowest. They give us the number of values for that range, what our overall spread is in referencing towards. Then we would come to quartile 2. Quartile 2 is the median of the full set. Okay, the median of the overall set. Quartile 1 is the median of lower half, and then we have median of the upper half. So basically what this does is it breaks us into percentiles. Okay, or it breaks it into quarters, thus quartiles. That minimum is the smallest number. There's nothing below it. If we go to that second quartile, that means we would have 25% below this number right here. On that median, that means that this number is at 50th percentile. 50% of our data is below, 50% is above, so it kind of breaks it up. The third quartile, thus 3/4, 0.75, 75%. So 75th percentile is below this. And then 100 percentile. So I'm kind of bringing in that percentile word too into this. You guys taken standardized tests before. You've been told, oh, I'm on the 80th percentile. I'm on the 90th percentile. I'm on the 40th percentile. Well, what does that mean? That means that's a percentage of people below your score. Okay, you are at that level, and then people are below you. So the higher your number, the more people that are below you. Later on, we'll discuss in that last section in this chapter about a normal curve and not having a straight like a box and whisker plot when we talk about a normal curve and what outliers there are and what gifted really means. Those of you that think, oh, I'm on the 99th percentile, I'm gifted, I have to tell you you're wrong. But we'll go through that a little bit as we go down the road, just because I don't like to crush bubbles, but it is just something that we need to address in here when we talk about normality. But we're in the box and whisker plots, so veering off on this, let's get back to our topic in here. Now, one of the main things with the box and whisker plot is we always want to have some sort of number line below. Okay, so we have to have this number line, and we want to have very equal spacing like I have right here, perfectly equal. Took my ruler out and measured, as you see. Just so that way we can kind of tell what's going on. So we would have our values. Let me just kind of go like this and make up some numbers right here for you. We would have our min and then our max. They would be that whisker section of this box and whisker plot. In that box portion, we would have our 3 quartiles, okay, in which then each line would be the value for that quartile. Referencing what's going on here, thinking about what's going on, we talk about the distance between quartile 3 minus quartile 1 to be called the interquartile range. Okay, so this interquartile range. Now, why is this important? Let me come back here to our outliers. Okay, an outlier could be distinguished between 1.5 times the interquartile range. And basically what we would do is we would take quartile 1 minus this number, and we would take quartile 3 plus this number. And what we would be looking for is we would be looking for a value that would be outside. So for instance, let's say my box and whisker plot was this small right here, but then I have this whisker that's out this far. What we would be looking for is this interquartile range has this distance. We would take 1.5 of that distance. So here would be 1, and then half would be about right here. Once again, this is visually looking at this on the box and whisker plot. And if this maximum number is still outside what this number here is, that's what's known to be an outlier. Okay, and we can do it also the other way if we subtract off. So if we know quartile 1 and then we subtract off this number, then we look for that lower number. And those numbers basically just don't make sense with the way our data is presented. They're too far off from what our inside is telling us of these values. Okay, so this is the second approach to finding that outlier. Once again, I'm kind of jumping all over, but there's a lot to cover in this section. Much of it has been covered before, so I'm not going to get too in-depth onto everything that's going on. So let's look at some basics going on. First off with finding outliers, mean, median, mode, range, okay, box and whisker plots. So we're going to use number 10, but I'm going to expand out number 10 just to do a whole bunch of stuff with it. Save some time, I wrote out this for us as I paused the video, and then now we can kind of continue on. So this is set number 10. There are 10 numbers right here given to us. And it tells us to find any outliers. Let's go through the whole process of everything. So you can just see a complete example of everything I kind of just discussed towards. So if we consider the numbers in order, okay, let's look at finding our mean, median, mode, and range. Okay, so in this mean, we're basically going to add up all these numbers. So generally when I write the numbers, I never write the original problem. I would write them in order from least to greatest, and then I would just go from here from what I'd be using. So the mean, I'm going to add up all of these. which when I add this up, I get 142, and I'm going to divide it by 10, because there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers here. So we see that we have 14.2. Once again, just going to decimal for purposes of comparing. Our median. In order to find the median, we're going to have to find the middle. So what we see here is we see that we have 5 numbers here, 5 numbers here. So our median is going to be in the middle of this. If I take 15 plus 16 divided by 2, or find the median of these two numbers, once again giving two numbers, the mean and median are going to be the same, we get 15.5 right here. Our mode, once again, appears more than once. So 19 is the only one that appears more than once. If none of them appeared more than once, then we would have no mode. And if we had multiple ones, then all of those would be mode. Once again, if we had one that appears 3 times, then this one would be trumped with this other one. Those who play Pinochle know what I mean by being trumped on this. And then our range, we're going to look at taking 21 minus 0, so 21 is our overall range. Okay, so this all has nice values to do within here and what we're trying to find. Now, common sense-wise, if we're thinking outlier, okay, we would be looking at 0. I mean, we see numbers 10 through 21, 11, 14, 15. It's like they're increasing very gradually or there, but 0 to 10 is a huge jump in comparison to what the jumps are in between all of them. So we'd be thinking 0 is an outlier. But how do we truly test that 0 is this outlier within? So what we kind of need to do is let's create a box and whisker plot. Okay. So if we think about this, we need our 5-number summary. So we have a min, quartile 1, quartile 2, quartile 3, and max. If you notice, 0 and 21 are already given to us. Once again, they come from our range. The median of 15.5 overall. Now what we need to do is we need to look at the fact that we need to find quartile 1 and quartile 3. In order to find quartile 1 and quartile 3, we have to go back to our set of data and we have to look at our lower half. Now, once again, because we have an even number, that means that this number is not actually part of our set. So 15 will be included in the lower half. Okay, 16 will be included in the upper half. So now finding the median right here, we see that 11 is in the middle of these 5 numbers. So we write 11, and then we see that this first 19 right here is in the middle right here. So we see this 19. If we are to graph our box and whisker plot, I can go 0, 5, 10, 15, 20, 25. Once again, we want to kind of know what our numbers are. We would plot a dot here for our 0. 11 would be our first, so that would be about right here. 15.5, and then 19, and then 21 would be about right here. So we would see that we would have this. Once again, if the numbers are not listed here, we would write these numbers right along with this graph. That way we know what the numbers are. But if we're listing the numbers out before we graph this, I can easily distinguish what these numbers should be, once again, because of the hand-drawn graphs that we're doing. The interquartile range. The interquartile range is 19 minus 11. So that would be 8. Okay. So if we take 19 minus 11, we get 8. Now, one of the things we're going to look at is we're going to take 1.5 times that interquartile range. So that's 1.5 times 8. So 1.5 times 8 equals 12. Okay. Now, if we look at our box and whisker plot, this whisker right here is absolutely close. I mean, it's so close in here, we're sure that it is. But this one here seems pretty far away. So we're wondering, well, maybe this is a pretty huge jump that could be in here. So what we would do is we would take our 11, so it's going to come up here, our 11, and we would subtract off 12. And then we would see negative 1 would be our value. So that means any number outside of this negative 1 right here would technically be considered an outlier. So for this problem, if we're looking at it, what we thought 0 was an outlier really isn't. I mean, it's close enough. Now, it is quite a ways out there to where common sense-wise we can still call it an outlier, but it really isn't that horribly off given our spread in the middle here, because we have such a wide spread with our middle numbers. That's thus allowing this number to technically not be an outlier. Okay, so to answer question 10 for an outlier, this one could go both ways. We could say 0 is an outlier just because it's not reasonably fitting with the data, but mathematically, technically it's not. And do realize that this is one of the reasons in math that there are so many discrepancies out there, is because we can sit here and try to figure out, well, what's going here, what's going there, but we can't truly work with values that we have known, because sometimes it depends on how we want to report it. I can report visually that this is an outlier, it's not looking like it's part of the set here, and report it that way. Because that is mathematically sound. It is not common to have a 0 when all my other ones are in 10s and 20s. But if I want to go numerically and formula-wise, I could say, no, that's not an outlier. We can perfectly have this. That's where the writing aspect, once again, as we talked about the writing and that statistics there, really comes into play, and why, as you as a consumer, as a person out there, when somebody does a study and says, oh, we got this study and we have this data and this is what we're reporting, how are they reporting it? Because it all depends upon interpretations. Think about what's currently going on with our virus out there. They're reporting things that this is not an outlier, this is an outlier. Well, how are they doing it? Are they fully divulging how they figured out this is going? Did they use a formula? Did they use something else? Now, once again, there are more than one ways to determine this. I'll go over the normal curve in section 1110. So it's down the road, so you'll see a different way to start considering what's happening there. But that's what this kind of gets into. So let's continue on and let's look at number 12. Okay? So we're given here a set of 11 numbers, and it's asked us to create a box-and-whisker plot. So on the last one, I really expanded out that whole outlier using common sense to proper ways, doing a whole bunch of stuff with on number 10. Number 12, we're really just going to do the box-and-whisker plot for this one, simply because the previous one had 10 numbers, so you have an example of how to do it for 10 numbers. Now on 11 numbers, we'll have an example to do it on here. So for that box-and-whisker plot, we need the minimum, quartile 1, quartile 2, quartile 3, and then the maximum number that we have. Well, once again, because when I wrote these down, I wrote them in order from least to greatest right off the bat. So we can go 11 and 20 right here. Now what we have to do is we have to find the middle number. Now in order to find the median here, we'll have to go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we see that right here we have 5 numbers and 5 numbers. Now notice what I did here is this is a direct middle. So that means it is not part of my lower half. It is not part of my upper half. It is directly in the middle here. So this is my overall median. So now to find my quartile 1, I'm going to exclude this median right here. Now if this was an even number, that even number on the past right here, remember that even number was in between these. We did not include the median in this. So we do not include the median here. We're following the same pattern on this. So by excluding this, now we look here and we see we have 5 numbers below this. So we look for the middle of these 5 numbers, in which then we have 2, 2, and then the middle one right here of 12, middle one right here of 19 on our upper part. So now we go to our number line. If I start at 10, and then I put 15, and then I put 20 right here, we can plot our ones. Now you can go in order. You can do this however you want. You can start in the middle. I can go my ends, my middle, and then now I can go to 12. 12 would be approximately right here. 19 would be approximately right here. We draw our box, and then we have our whisker. Seeing that everything is really close in here. So this definitely, mathematically or observational-wise, common sense-wise, has no outlier in this one. Kind of relating it back. But this is how we do that in a box and whisker plot. Now, on this, we were asked about percentiles. Okay, if I wanted to know what the 50th percentile is. Okay, let me spell it correct. Percentile. Okay, the 50th percentile. Well, we're given directly what the 50th percentile is right here. It is 15. Okay, so the score of 15 is that 50th percentile. But let's say I wanted something a little more different. Let's say I wanted to know what the 80th percentile was. Okay, so if I want to know the 80th percentile, what we would have to do is we have to take our total amount of numbers and multiply by that percentile. So if I take my 11 numbers and multiply by 80%, or the 80th percentile, we see that 11 times 0.8 equals 8.8. Okay, so 8.8. Now, this is where we have to start using a little discrepancy in here and be thinking about what is a percentile. The percentile means that this has to be below the number that we're referencing. Okay, so it has to be below that number that we're referencing. So we're going to round up to then the 9th number. If this was 8.2, I still would round up to that 9th number. Okay, because once again, the 8th number in here, this 8th number in here is not going to be below. So even if this was 8.2, okay, so I go 1, 2, 3, 4, 5, 6, 7. Here's the 8th number, and then here's the 9th number. If I select this 8th, that means that everything below this, I want the 80th percentile, so I have to use some rounding judgment in here, in which then I would state that 19 is the 80th percentile. Okay, once again, because 80th percentile means that 80% of the numbers are below this. So 8 out of those 11 are below this. Now, once again, this is a very small set of data, so there is some discrepancy, but always remember the percentile talks about what's below those numbers, and that's what we're referencing towards. And that's where, like, when we talk about this, we talk about the 25th percentile, the 50th percentile, the 75th percentile. Notice that 75th percentile was this number right here. So we talk about the 80th percentile. Oh, wait, it still has enough once again because of all this going into play.